When we started looking for exoplanets, we thought we'd find worlds like the ones in our solar system. But reality turned out to be rather more complicated than that. When you find an exoplanet, there are two things you should care about. The first is the size. So we're going to put big planets up here and small planets down at the bottom of the graph here. The other factor that matters is how much starlight your planet receives. That determines its temperature and the environment in which it lives. So we'll put hot planets down in the bottom left, and we'll put cold planets over on the right-hand side. Now, the first exoplanet was found in 1989, so we'll put that one up. And then by 1999, we'd already found a whole host of worlds, and we could see that things were going to be rather different. These planets up here are hot Jupiters. They're large, like Jupiter or Saturn, but they're much closer to their stars than Mercury is to the Sun. So these are unusual planets, the kind that we don't have in our solar system. Now, 10 years on, we've really begun to fill in the smaller planets. We've got plenty of Neptune-sized worlds and plenty of Earth-sized worlds down here. In fact, the most common size of planet are these green ones on the graph, these Neptune-sized planets. In fact, there's an awful lot of planets that are smaller than Neptune, but bigger than the Earth, what are called super-Earth planets. That's a common type of planet that we turn out not to have in our solar system. Now, we can label this diagram according to the types of planets. So we've got the cold gas giants. We've talked about the hot Jupiters in the top left here. The ice giants in between, Uranus and Neptune in our solar system, but here much closer to their stars than those distant worlds are around here. In the bottom left, my favorite kind of planet. These were completely unexpected. The lava worlds, Earth-sized worlds that are so close to their stars that the temperature on their surface would be high enough to melt rock. So you certainly couldn't stand there. And we don't know how these worlds formed. They can't have formed in situ. Maybe they were the hot Jupiters of the past. They've had their atmosphere boiled away by spending too much time close to their star. The part of the diagram that gets most attention is down here in the bottom right. If we zoom in, we can put up some crosshairs for Earth. So we would lie smack in the middle here. And we're beginning to find planets that are pretty close to being Earth-like. They get the same amount of light and they're the same size. There's Proxima Centauri's planet, our nearest exoplanet, TRAPPIST-1e in the multi-planet system that people get very excited about. And then a new discovery, Teegarden B, almost the most Earth-like planet we know, a planet around Teegarden's star, a small red dwarf just 12 light years away. So we are finding that around our nearest stars, we can detect properly Earth-like planets.